Hello everyone. In this video we're going to be going through number of islands, which is LeetCode problem 200. So this is marked as a medium problem and it's super popular. Given an m times n 2D binary grid called grid, which represents a map of ones, which is the land, and zeros, which is water, return the number of islands. So what is an island? An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume that all four edges of the grid are all surrounded by water. So if we look at example 1 here, we take this one and you see it's connected horizontally to the right with all these other ones. And this one is connected to this one. These two are connected to these two, and these two are connected to these two. So there's basically one island in this example. In example 2, we've got these two ones and these two ones, but surrounding it are zeros. And notice this doesn't count. The diagonal is not considered part of the island. So this is one island. Then this island is also another island because you've got 0 above, below, to the right, and to the left. And then finally you have this other island of these two ones. So that, and the output is 3. So that is what they're looking for. Alright, so let's see how to do this. Alright, so we're going to use what's called a depth first search. And it's basically we're going to traverse down, so deep or depth. We're going to traverse down before we traverse to the right. And this is explained here by this tree. 1, 2, 3, 4. We go down first, then we go over. Same here. We go over, and then we go down again and over and over. And when you see binary trees or graphs like this, you can always think some type of recursion because there's going to be a lot of repetitive action. Alright, so this is the method we're given. We pass in an array of arrays called grid, and the return value is an int, which is the number of islands. So the first thing we'll take care of the easy stuff first. The grid is null, or the length is 0, just return 0. There are no islands whatsoever. So then we're going to declare a variable called num_islands and assign it to 0. And this will be the return value of this method. So what we're going to do is we have to loop through every item in this grid, or every element. So we're going to start with the I is equal to 0, less than grid length. So grid length in this case is 4. So 1, 2, 3, 4 arrays. And then j is actually going to traverse through each item in the array. So this is going to be grid I length. Now if we come across a 1, if grid ij equals 1, then we got to do some stuff. And this is where this recursion comes in. So we're going to call this method DFS, or depth first search, passing in the entire grid as well as I and j. And that is it for that return. I always forget the return value. And then of course we return the number of islands at the end. Okay, so that is the method, but what we need to do is figure out how to build this DFS method, which is the meat of this entire problem. Okay, so we've got this DFS method passing in the array of arrays as well as I and j, and we're going to pass back an int. Okay, so when you do recursion, you want the ability to return 0, which breaks you out of the instance of the recursion. So if I is less than 0, in this case, I is less than 0 or j is less than 0. So if we do anything outside the bounds of this grid, then it's going to be less than 0. I is greater than the grid length, and j is greater than or equal to grid I length. So like if the value is over here, well that's greater than the length of that particular array. Or grid ij equals 0, then return 0. So you're like, well, we just passed in a grid that equals 1, so how can it equal 0? Well, we're going to assign it to 0. So the first thing we do is we take the value and assign it to 0. So in other words, once we have captured this 1, we don't want to deal with it anymore. We don't want to count it twice. So we basically sync it, or we're going to sync the islands. We're going to convert this to a 0, and then we'll look at all these other ones, and eventually this entire grid will be all zeros. The first thing we're going to do is check below. So I plus 1. So if I is 0, I plus 1 will be this value. And the j stays the same. So check below, then we'll check above, which is I minus 1. So we'll check up here. And then we check to the right, which is j plus 1 over here. And then j minus 1 we'll check back. So this is checking to see if there's a 1 on all corners of this 1 that we have found. And then we're going to return 1 after this is all done. And that ends the if statement and ends the method. Alright, so I feel like this is always explained better with the debugging. I'll get my handy dandy graph here. Okay, so what I did was pick the second example. So we're going to have 1 island, 2 islands, and 3 islands. So let's traverse this and see what we come up with. Alright, so we have this grid here, which is basically a reproduction of the grid on the left here. It's not null, length is not 0. Assign num islands to 0. So we're going to go through each row. Each row. So we're going to go through the first row here. I is 0, and j is 0. So that's immediately we find the 1. So now we've got to go into this DFS method, passing in 0 and 0. Okay. Here is where the fun begins. All right. So we're going to assign grid 0, 0 equal to 0. So if you look at the grid now, this value that used to be a 1 is now a 0. So let's check below. And voila, I1, 0 is also 0. So now if we look at the grid, this is also 0 down here. And so now we're in the, now we're going to check, we increase I to 2, which that is equal to 0. So now we're going to move on to I equals 1, j equals 0. We're going to check above, which that will also return 0, there's nothing above. So now we need to check right. And we find a value right on I1, J1, so that's right here. And so we assign that to 0. So now if you look at the grid here, we've got 3 zeros. The only one left is this one. So there's nothing there, all zeros. Oh, I'm sorry. Okay, so we got 0 and 1. So that's 0, or I is equal to 0 and j equals 1. And so now that gets converted to 0. So now we have basically sunk that entire island. However, if you look down here, we have 4 instances of DFS. So we need to, that's kind of the downfall of using recursion, is we have all the answer we need, but we still have to traverse all these other DFS calls. So basically when you, like let's say we're on this one, we've got to check its value left, right, up, and down. Same with this. So we've got to basically finish out the DFS method with all these other calls, even though we technically don't need them. But so anyway, all these are going to return 0. 0, 0. We're just cleaning up the methods. 0 and 1. That's also 0. Okay, so then now we've taken care of 0, 1. So now we need, if you look down here, you have, so this is what's going on here. Yeah, so this is when I is 1 and j is 1. This one is when I is 1 and j is 0. And this is when I is 0 and j is 0. So we need to check left, right, up, and down for each one of those. So now we're on 1, 1. I is 1, j is 1, and there is nothing to the right. So that will just return 0. Then we'll go down to the left. I is 1, j is 1. There's nothing to the left of that because we just zeroed it out. And so that will return 1 as well. All right, so now we're down to I is 1, and j is 0. So we're going to check to the right, that's 0. Check to the left, that is also 0, so we're going to return 1 there. And finally, we're doing 0, 0. If you remember, we started this whole check with checking below the first 1, which was at 0, 0. So now we need to finish out above, right, and left of this. And so these are all zeros because we've zeroed all those out. All right, so now we are done with that. This is still the 0, 0. When you look at the grid now, we've basically sunk that island. There's nothing left. But we have a value of 1. So num islands is 1. So now we're going to continue with j on where I equals 0, but we've zeroed everything out, so it won't find anything. 0, j is 4, 0. Okay, so now we're back to I. So now we're into, where is it? Yeah, now we're into I equals 1. So we're into the second row, which those are all zeros too, so it's just going to keep, it doesn't find a 1. Now we're on to I equals 2. So I equals 2, we're going to find a 1 at j equals 2. So let's see, j equals 0, j equals 1. Okay, now we should pop into that method, and we do. Passing in j equals 2, or I equals 2 and j equals 2. So if you go 0, 1, 2, 0, 1. So this is this one right here. And this should be a quick one because it doesn't have anything to the left, right, up, or down. So we're going to zero out that value. Look at the grid. It's now gone. There's nothing to the right, below, nothing above, nothing to the right, and nothing to the left. So yeah, that was pretty quick. All right, so we're going to continue to check. Yeah, there won't be anything. There won't be any ones in the rest of that row. Okay, so now we're on to the last row. I equals 3. J is 0, j is 1, nothing there. J is 2, j is 3. Okay, now we found a 1, which is this one right here. All right, so we zero that out, and looking at the grid, 0 value. Now we're going to check below, there's nothing. We're going to check above, there's nothing. We're going to check to the right. Winner, winner, chicken dinner. We have a 1 to the right. So we zeroed that out, and you see now the entire grid is 0. Okay. So now we've got to, because we found something to the right, now we've got to check up, down, left, right for this 1 at position 4, 4. So we'll do that, and they didn't find anything, doesn't find anything, doesn't find anything. Return 1 there. Now we're back to I is 3, j is 3, which is this one. And there's nothing to the right, nothing to the left. We've zeroed it all out, and we're back. And we should just finish out with a number of islands equal 3. And that is how you do that problem. Hopefully that makes sense. The last thing we'll do is go through the space and time complexity. Okay, so time complexity is O of n. We've got, it's actually O, this is messed up. It's actually O of m plus n. So we do 2 loops. So we do m plus n there. And the space complexity is, it's actually also O of n plus n. We've got, because we've got the 2 loops, we have, we take into consideration the bigger the arrays get, the more items we have to go through in those loops. And so O of m plus n, which is the requirement of LeetCode, is to have O of m plus n complexity on both of those. All right, sorry for that blooper there at the end, but this is a 14-minute video, so I don't feel like re-recording it. Anyway, let me know if you have questions. Thanks for watching, and we'll see you next time.